An Introduction to Linear Programming.
Linear Programming Introduction. Sometimes we want to find two numbers, let's say x and y, that satisfy a set of inequalities. We've seen that if we have a set of inequalities, we can draw a graph of the situation, and there's an area that satisfies all the inequalities. That is, all the points in that area are solutions to the problem. Let's look at an example. A shop wants to post 25 books in boxes. A large box holds 5 books, and a small box holds 2 books. The shop has 4 large boxes and 7 small boxes. In the first part, we have to write down 5 inequalities and draw a graph to represent the information. To do this, let x and y be the number of large and small boxes respectively. Now obviously we can't have less than 0 boxes, so we have x is greater or equal to 0 and y is greater or equal to 0. The number of large boxes is less than or equal to 4, so x is less than or equal to 4. The number of small boxes is less than or equal to 7, so y is less than or equal to 7. Now the amount of space that we have is 5 times the number of large boxes plus 2 times the number of small boxes. So 5x plus 2y must be greater or equal to 25 if we're going to post all 25 books. Well, we can draw the graphs of these inequalities. First of all, if x is greater or equal to 0, that means we're going to shade out all the values of x that are below 0. If y is greater or equal to 0, we're going to shade out all the values of y that are less than 0. Now we have x is less than or equal to 4, so we can draw a vertical line crossing the x-axis where x is equal to 4, and we want to shade out the right-hand side because that represents all the values of x that are greater than 4. Similarly, if y is less than or equal to 7, we can draw a horizontal line going through the y-axis at y equals 7 and shade out all the values of y that are above 7. Finally, we draw the graph of 5x plus 2y equals 25. Now we want to shade one side of that line. If we choose the values x is 0 and y is 0, then we have 0 is greater or equal to 25, which is false. We shade out the false side, and so we shade out the side containing the point 0, 0, the origin. Now in part 2 we're asked, what is the least number of boxes needed? Well, if we look at the graph we've drawn, all the points that are in the unshaded region or on solid lines are possible solutions. So they are 4, 3, 4, 4, 3, 5, 4, 5, 3, 6, 4, 6, 3, 7 and 4, 7. And we can put these in a table. Now we can add an extra row called x plus y, which is the total of all the boxes. So in the first column we've got 4 large and 3 small boxes, which is a total of 7 boxes. Then we have 4 plus 4 is equal to 8, 3 plus 5 equals 8, 4 plus 5 equals 9, 3 plus 6 equals 9, 4 plus 6 equals 10, 3 plus 7 equals 10, and 4 plus 7 equals 11. So we see the smallest number of boxes is 7, with 4 large and 3 small. In part 3 it says, if it costs £1 to post a small box and £2 to post a large box, what is the cheapest method? Now, we can add a 4th row to our table, and this can be 2x plus y. The reason for that is that each large box, x, costs £2, and each small box, y, costs £1. And that gives us 2 times 4 plus 3 is equal to £11. 2 times 4 plus 4 is equal to £12. 2 times 3 plus 5 is equal to £11. 2 times 4 plus 5 is equal to £13. 2 times 3 plus 6 is equal to £12. 2 times 4 plus 6 is equal to £14. 2 times 3 plus 7 is equal to £13. And 2 times 4 plus 7 is equal to £15. And so we see from the table, the cheapest price that you can post them for is £11. Now that can be done two ways. It can be done as 4 large and 3 small boxes, or 3 large and 5 small boxes, but either method costs £11. Now let's look at this problem again. Supposing we have the same problem and we draw the same graph. When we get to part 2, instead of drawing a table and looking at all the possibilities, we can read off the information just from the graph. And the way we do it is this. The question says, what is the least number of boxes needed? Well, let n be the number of boxes needed. Then n is equal to x plus y. Now x plus y equals n is a family of parallel lines, all with gradient -1. For the smallest n, we want the line closest to the origin. So, if we draw the line x plus y equals 0, and then slide it out until it reaches the first point in the unshaded region, we get in this case, it reaches the point 4, 3 first. Now that is 4 large and 3 small boxes, so it's a total of 7 boxes. So we have the minimum number of boxes needed is 7. Now in part 3 we're asked if the cost is £1 to post a small box and £2 to post a large box, what is the cheapest method? So to do this, let's write down that the cost C is equal to 2x plus y. Now again, 2x plus y equals C is a family of parallel lines. So if we draw the graph of 2x plus y equals 0, and then slide it out until it reaches the first point in the unshaded region, we get there are 2 points, 3, 5 and 4, 3. Now 3 large boxes and 5 small boxes cost 3 times £2 plus 5 times £1, which is £11. And 4 large and 3 small boxes cost 4 times £2 plus 3 times £1, which is equal to £11. And so the minimum cost is £11.